evening, everyone. My name is Lyhour You. Today, I would like to talk about harmonic component of the decay current as a diagnostic tool to study the aging of the insulator. I divide my presentation into 5 parts. First of all, the motivation. We will show what is an insulator.
Please check off your device.
Secondly, the problem statement will be address what is a main factor of the aging, and thirdly, the proposed solution will show the experiment design, and fourthly, the result will be show the relation between the decay current and the harmonic component, and lastly, the conclusion is demonstrated. So generally, insulator is used to prevent the electrical flow between the conductor or between the conductor and other material. Additionally, because insulator has a high resistive, so it can protect people and equipment from damage as well as prevent the short circuit which can cause the fire or damage to the system. Furthermore, insulator itself can maintain the circuit integrity by preventing unwanted decay current or interference from its node source. So once again, if the power utility can identify or replace the damaged or polluted insulator in time, it can improve the reliability of the power system as well as the safety of the power transmission system during the maintenance. So this is an example of the clean insulator and the polluted insulator. You can see that the polluted insulator have a crack on its surface. So insulator can degrade over time due to various factors. First of all, since the insulator is used outdoor, so it exposed to weather conditions such as rain, wind, or snow. Secondly, the temperature change can make the insulator expand or contract, which can damage itself. Thirdly, the chemical from acid rain or from industrial pollutant or can be from animal waste which deposit on the surface of the insulator. It can contaminate and leading to the crack. Thirdly, the insulator is subject to the mechanical stress from the wind and vibration, so insulator can lose over time. So lastly, over time, the insulator itself loses its effectiveness. So this is the main objective of this journal, to identify which aging insulator. So the third part is experimenting design. So there are total of 19 insulator, which there are 4 new insulator and 15 old that they use from the field. So from the equivalent experiment circuit, first of all, we have to supply the voltage 240 volt on S to the V rack, and then we supply into the insulator, and we'll measure the power system for 5 times, and for each insulator, and we do statistic analysis from the Microsoft Excel. So this is the result from the decay current. We can see that the decay current from the new insulator is more or less is less than the decay current from the egg insulator. And from the statistic point of view, we can see that harmonic order number 3, number 5, number 7, so the positive treatment effect, and the mean power of the egg insulator is higher than the new insulator. So this is overall of the experimenting result, we can clearly see that the third harmonic component is slightly increased as well as the fifth and seventh, but the ninth did not show any positive effects. And the graph is shown about the leakage current. The purple one is a new and the red one is a aged insulator. So in conclusion, the third harmonic is a main indicator of the aged top 10 glass insulator, and the researcher also noted that there is a slightly increase of magnitude in the fifth and seventh harmonic component. So based on the finding, when we monitoring harmonic component of leakage current, it can be a useful tool for the power utility to identify the aged insulator. That's all for this session.
Okay. Richard?
Can you do that one slide? 9. This is the number of layers 1 to 15 air insulator sample.
Yeah, this is a field insulator 1 to 15.
So in this graph, we can see that at the 1, the air insulator is high value.
Yeah,
Yeah.
the leakage current from the aged insulator is higher value than the.
But for the 2, it is low.
Yeah, for the new insulator is lower.
No, not for the new one. For the number 1, air insulator's value is almost 3.18 something.
Yeah.
Yeah, and for the second one, it is the value almost 3.05. So it is the random values that it go up and down or takes an effect, or it will be simultaneously changed.
We can see that it's random up and down, but it's larger than the.
Yeah, it
New
is larger
insulator.
than that, but I am confused that for one, if it is high, then second for it will be maybe most higher than one, and then
Yeah, it's just random, but it's always higher than the new insulator.
Okay, hold on.
In this research, electrical breakdown affect this result. Does electrical breakdown affect this result?
Yeah, because the insulator can be flash over breakdown.
Okay.